Basic electricity. Question. The working voltage of a capacitor in an AC circuit should be. Answer. At least 50% greater than the highest applied voltage. Question. The term that describes the combined resistive forces in an AC circuit is. Answer. Impedance. Question. What is the opposition to the flow of AC produced by a magnetic field with generated back voltage, EMF, called? Answer. Inductive reactance. Question. Electrostatic fields are also known as. Answer. Dielectric fields. Question. The basis for transformer operation and the use of alternating current is mutual. Answer. Inductance. Question. The opposition offered by a coil to the flow of alternating current is called. Disregard resistance. Answer. Inductive reactance. Question. What factors strengthen a coil inductor? Answer. Adding coils close together. Question. An increase in which of the following factors will cause an increase in the inductive reactance of a circuit? Answer. Inductance and frequency. Question. Refer to Figure 1. When different rated capacitors are connected in series in a circuit, the total capacitance is. Answer. Less than the capacitance of the lowest rated capacitor. Question. Capacitors are sometimes used in DC circuits too. Answer. Smooth out slight pulsations in current/voltage. Question. In an AC circuit, the effective voltage is. Answer. Less than the maximum instantaneous voltage. Question. The amount of electricity a capacitor can store is directly proportional to the. Answer. Plate area and inversely proportional to the distance between the plates. Question. Refer to Figure 2. What is the total capacitance of a certain circuit containing three capacitors with capacitances of 0.02 microfarad, 0.05 microfarad, and 0.10 microfarad, respectively? Answer. 0.0125 microfarad. Question. What is the total capacitance of a circuit containing three capacitors in parallel with capacitances of 0.02 microfarad, 0.05 microfarad, and 0.10 microfarad, respectively? Answer. 0.0125 microfarad. Question. What is the total capacitance of a circuit containing three capacitors in parallel with capacitances of 0.02 microfarad, 0.05 microfarad, and 0.10 microfarad, respectively? Answer. 170 F. Question. Convert farads to microfarads by. Answer. Multiplying farads by 10 to the power of 6. Question. Convert farads to picofarads by. Answer. Multiplying farads by 10 to the power of 12. Question. Unless otherwise specified, any values given for current or voltage in an AC circuit are assumed to be. Answer. Effective values. Question. When different rated capacitors are connected in parallel in a circuit, the total capacitance is. Note, CT equals C1 plus C2 plus C3. Answer. Equal to the sum of all the capacitances. Question. When inductors are connected in series in a circuit, the total inductance is, where the magnetic fields of each inductor do not affect the others. Note, LT equals L1 plus L2 plus L3. Answer. Equal to the sum of the individual inductances. Question. Refer to Figure 3. When more than two inductors of different inductances are connected in parallel in a circuit, the total inductance is. Answer. Less than the inductance of the lowest rated inductor. Question. What is the total capacitance of a certain circuit containing three capacitors with capacitances of 0.25 microfarad, 0.03 microfarad, and 0.12 microfarad, respectively? Note, CT equals C1 plus C2 plus C3. Answer. 4F. Question. Question. Which requires the most electrical power during operation? Answer. Two lights requiring 3 amperes each in a 24-volt parallel system. Question. How much power must a 24-volt generator furnish to a system which contains the following loads? Unit rating. 1 motor, 75% efficient 1/5 of a horsepower. 3 position lights 20 watts each. 1 heating element 5 amp. 1 anti-collision light 3 amp. Note, 1 horsepower equals 746 watts. Answer. 450 watts. Question. A 12-volt electric motor has 1000 watts input and 1 horsepower output. Maintaining the same efficiency, how much input power will a 24-volt, 1 horsepower electric motor require? Note, 1 horsepower equals 746 watts. Answer. 1000 watts. Question. How many amperes will a 28-volt generator be required to supply to a circuit containing 5 lamps in parallel, 3 of which have a resistance of 6 ohms each and 2 of which have a resistance of 5 ohms each? Answer. 25.23 amperes. Question. A 1 horsepower, 24-volt DC electric motor that is 80% efficient requires 932.5 watts. How much power will a 1 horsepower, 12-volt DC electric motor that is 75% efficient require? Note, 1 horsepower equals 746 watts. Answer. 994.6 watts. Question. The potential difference between two conductors which are insulated from each other is measured in. Answer. Volts. Question. Which effect does not apply to the movement of electrons flowing in a conductor? Answer. Static energy. Question. A 24-volt source is required to furnish 48 watts to a parallel circuit consisting of 4 resistors of equal value. What is the voltage drop across each resistor? Answer. 24 volts. Question. Question. When calculating power in a reactive or inductive AC circuit, the true power is. Answer. Less than the apparent power. Question. Refer to Figure 4. How much power is being furnished to the circuit? Answer. 2,645 watts. Question. Question. Refer to Figure 5. What is the impedance of an AC series circuit consisting of an inductor with a reactance of 10 ohms, a capacitor with a reactance of 4 ohms, and a resistor with a resistance of 8 ohms? Answer. 10 ohms. Question. Refer to Figure 6. If resistor R5 is disconnected at the junction of R4 and R3 as shown, what will the ohm meter read? Answer. 3 ohms. Question. Question. Refer to Figure 7. If resistor R3 is disconnected at terminal D, what will the ohm meter read? Answer. Infinite resistance. Question. Refer to Figure 8. With an ohm meter connected into the circuit as shown, what will the ohm meter read? Answer. 10 ohms. Question. Question. Refer to Figure 9. How many instruments, voltmeters and ammeters, are installed correctly? Answer. 2. Question. The correct way to connect a test voltmeter in a circuit is. Answer. In parallel with a unit. Question. What will a voltmeter read if properly connected across a closed switch in a circuit with electrical power on? Answer. 0 voltage. Question. What does the letter Q symbolize when measuring electrical charge? Answer. Answer. Coulomb. Question. Which term means 0.001 ampere? Answer. Milliampere. Question. A cabin entry light of 10 watts and a dome light of 20 watts are connected in parallel to a 30-volt source. If the voltage across the 10-watt light is measured, it will be. Answer. Equal to the voltage across the 20-watt light. Question. A 14-ohm resistor is to be installed in a series circuit carrying 0.05 ampere. How much power will the resistor be required to dissipate? Answer. At least 35 milliwatts. Question. 002 kV equals. Answer. 2.0 volts. Question. Refer to Figure 10. What is the measured voltage of the series parallel circuit between terminals A and B? Answer. 3.0 volts. Question. Refer to Figure 64. A 24-volt source is required to furnish 48 watts to a parallel circuit consisting of 2 resistors of equal value. What is the value of each resistor? Answer. Answer. 24 ohms. Question. Which requires the most electrical power? Note. 1 horsepower equals 746 watts. Answer. A 1/5 horsepower, 24-volt motor which is 75% efficient. Question. What unit is used to express electrical power? Answer. Watt. Question. What is the basic unit of electrical quantity? Answer. Coulomb. Question. What is the operating resistance of a 30-watt light bulb designed for a 28-volt system? Answer. 26 ohms. Question. When referencing resistance in a parallel DC circuit, which of the following statements is true? Answer. The total current is equal to the sum of the currents through the individual branches of the circuit. Question. Which of the following is commonly used as a rectifier in electrical circuits? 1. Anodes. 2. Cathodes. 3. Diodes. Answer. 3. Question. Diodes are used in electrical power supply circuits primarily as. Answer. Rectifiers. Question. Transfer of electric energy from one circuit to another without the aid of electrical connections. Answer. Answer. Is called induction. Question. If 3 resistors of 3 ohms, 5 ohms, and 22 ohms are connected in series in a 28-volt circuit, how much current will flow through the 3-ohm resistor? Answer. 0.93 ampere. Question. A circuit has an applied voltage of 30 volts and a load consisting of a 10-ohm resistor in series with a 20-ohm resistor. What is the voltage drop across the 10-ohm resistor? Answer. 10 volts. Question. Refer to Figure 11. Find the total current flowing in the wire between point C and D. Answer. 3.0 amperes. Question. Refer to Figure 11. Find the voltage across the 8-ohm resistor. Answer. 24 volts. Question. In a parallel circuit with 4 6-ohm resistors across a 24-volt battery, What is the total voltage across resistor 3, VR3, in the circuit? Answer. Answer. 24 volts. Question. In a parallel circuit with 4 6-ohm resistors across a 24-volt battery, what is the total voltage across resistor 3, VR3, in the circuit? Answer. 24 volts. Question. If each cell, connected in series, equals 2 volts, how would a 12-cell lead-acid battery be rated? Answer. 24 volts. Question. Refer to Figure 12. Find the total resistance of the circuit. Answer. 21.2 ohms. Question. Which is correct in reference to electrical resistance? Answer. If one of 3 bulbs in a parallel lighting circuit is removed, the total resistance of the circuit will become greater. Question. What happens to the current in a voltage step-up transformer with a ratio of 1 to 4? Answer. The current is stepped down by a 1 to 4 ratio. Question. Refer to Figure 13. Determine the total current flow in the circuit. Answer. 1.4 amperes. Question. Question. In a parallel circuit with 3 6-ohm resistors across a 12-volt battery, what is the total current, value in the circuit? Answer. 6 amps. Question. Refer to Figure 14. The total resistance of the circuit is. Answer. 17 ohms. Question. Which of these will cause the resistance of a conductor to decrease? Answer. Decrease the length or increase the cross-sectional area. Question. Question. Through which material will magnetic lines of force pass the most readily? Answer. Iron. Question. Refer to Figure 64. A 48-volt source is required to furnish 192 watts to a parallel circuit consisting of 3 resistors of equal value. What is the value of each resistor? Answer. 36 ohms. Question. Which is correct concerning a parallel circuit? Answer. Total resistance will be smaller than the smallest resistor. Question. The voltage drop in a circuit of known resistance is dependent on. Answer. The amperage of the circuit. Question. A thermal switch, or thermal protector, as used in an electric motor, is designed to. Answer. Open the circuit in order to allow cooling of the motor. Question. Refer to Figure 15. With the landing gear retracted, the red indicator light will not come on if an open occurs in wire. Answer. Number 19. Question. Question. Refer to Figure 15. The No. 7 wire is used to. Answer. Close the push-to-test circuit. Question. Refer to Figure 15. When the landing gear is down, the green light will not come on if an open occurs in wire. Answer. No. Question. Refer to Figure 16. What will be the effect if the PCO relay fails to operate when the left-hand tank is selected? Answer. The fuel pressure crossfeed valve open light will not illuminate. Question. Refer to Figure 16. The TCO relay will operate if 24 volts DC is applied to the bus and the fuel tank selector is in the. Answer. Crossfeed position. Question. Refer to Figure 16. With power to the bus and the fuel selector switched to the right-hand tank, how many relays in the system are operating? Answer. 3. Question. Refer to Figure 16. When electrical power is applied to the bus, which relays are energized? Answer. PCC and TCC. Question. Refer to Figure 16. Energize the circuit with the fuel tank selector switch selected to the left-hand position. Using the schematic, identify the switches that will change position. Answer. 5, 6, 11, 12, 13, 15, 16. Question. Question. Refer to Figure 17. Which of the components is a potentiometer? Answer. 3. Question. Refer to Figure 17. The electrical symbol represented at number 5 is a variable. Answer. Capacitor. Question. Question. Refer to Figure 18. When the landing gears are up and the throttles are retarded, the warning horn will not sound if an open occurs in wire. Answer. No. Question. Refer to Figure 18. The control valve switch must be placed in the neutral position when the landing gears are down too. Answer. Prevent the warning horn from sounding when the throttles are closed. Question. Refer to Figure 19. Under which condition will a ground be provided for the warning horn through both gear switches when the throttles are closed? Answer. Left gear up and right gear down. Question. Refer to Figure 19. When the throttles are retarded with only the right gear down, the warning horn will not sound if an open occurs in wire. Answer. No. Question. Refer to Figure 19. When the landing gears are up and the throttles are retarded, the warning horn will not sound if an open occurs in wire. Answer. No. Question. When referring to an electrical circuit diagram, what point is considered to be at zero voltage? Answer. The ground reference. Question. Question. What is the purpose of the ground symbol used in electrical circuit diagrams? Answer. To show that there is a return path for the current between the source of electrical energy and the load. Question. Refer to Figure 20. Troubleshooting an open circuit with a voltmeter as shown in this circuit will. Answer. Permit the battery voltage to appear on the voltmeter. Question. Refer to Figure 21. Which symbol represents a variable resistor? Answer. Answer. 2. Question. In a PNP transistor application, the solid-state device is turned on when the answer. Base is negative with respect to the emitter. Question. In an NPN transistor application, the solid-state device is turned on when the answer. Base is positive with respect to the emitter. Question. Typical application for Zener diodes is as answer. Voltage regulators. Question. Refer to Figure 22. Which illustration is correct concerning bias application and current, positive charge, flow? Answer. 1. Question. Question. Forward biasing of a solid-state device will cause the device to answer. Conduct. Question. Refer to Figure 23. If an open occurs at R1, the light answer cannot be turned off. Question. Question. Refer to Figure 23. If R2 sticks in the up position, the light will answer be on full bright. Question. Refer to Figure 24. Which statement concerning the depicted logic gate is true? Answer. Any input being 1 will produce a 1 output. Question. Refer to Figure 25. In a functional and operating circuit, the depicted logic gate's output will be 0. Answer. When 1 or more inputs are 0. Question. Question. Refer to Figure 26. Which of the logic gate output conditions is correct with respect to the given inputs? Answer. 2. Question. Which of the following logic gates will provide an active high out only when all inputs are different? Answer. XOR. Question. A lead-acid battery with 12 cells connected in series, no load voltage equals 2.1 volts per cell, furnishes 10 amperes to a load of 2 ohms resistance. The internal resistance of the battery in this instance is answer. 0.52 ohm. Question. Question. If electrolyte from a lead-acid battery is spilled in the battery compartment, which procedure should be followed? Answer. Apply sodium bicarbonate solution to the affected area followed by a water rinse. Question. Which statement regarding the hydrometer reading of a lead-acid storage battery electrolyte is true? Answer. The hydrometer reading does not require a temperature correction if the electrolyte temperature is 80 degrees Fahrenheit. Question. A fully charged lead-acid battery will not freeze until extremely low temperatures are reached because. Answer. Most of the acid is in the solution. Question. What determines the amount of current which will flow through a battery while it is being charged by a constant voltage source? Answer. The state of charge of the battery. Question. Which of the following statements is / are generally true regarding the charging of several aircraft batteries together? 1. Batteries of different voltages, but similar capacities, can be connected in series with each other across the charger, and charged using the constant current method. 2. Batteries of different ampere-hour capacity and same voltage can be connected in parallel with each other across the charger, and charged using the constant voltage method. 3. Batteries of the same voltage and same ampere-hour capacity must be connected in series with each other across the charger, and charged using the constant current method. Answer. 1 and 2. Question. The method used to rapidly charge a nickel-cadmium battery utilizes. Answer. Constant voltage and varying current. Question. The purpose of providing a space underneath the plates in a lead-acid batter cell container is to. Answer. Prevent sediment buildup from contacting the plates and causing a short circuit. Question. Which condition is an indication of improperly torqued cell link connections of a nickel-cadmium battery? Answer. Heat or burn marks on the hardware. Question. The presence of any small amount of potassium carbonate deposits on the top of nickel-cadmium battery cells in service is an indication of. Answer. Normal operation. Question. What is the likely result of servicing and charging nickel-cadmium and lead-acid batteries together in the same service area? Answer. Contamination of both types of batteries. Question. Which of the following best describes the operating principle in a nickel-cadmium battery installed in an aircraft? Answer. To completely charge a nickel-cadmium battery, some gassing must take place, thus, some water will be used. Question. The electrolyte of a nickel-cadmium battery is the lowest when the battery is. Answer. In a discharged condition. Question. The electrolyte of a nickel-cadmium battery is highest when the battery is. Answer. In a fully charged condition. Question. The end of charge voltage of a 19-cell nickel-cadmium battery, Measured while still on charge. Answer. Depends upon its temperature and the method used for charging. Question. During discharge, nickel-cadmium batteries will show a lower liquid level than when at full charge because. Answer. The electrolyte becomes absorbed into the plates. Question. How can the state of charge of a nickel-cadmium battery be determined? Answer. By a measured discharge. Question. What may result if water is added to a nickel-cadmium battery when it is not fully charged? Answer. Excessive spewing is likely to occur during the charging cycle. Question. In nickel-cadmium batteries, a rise in cell temperature. Answer. Causes a decrease in internal resistance. Question. Which of the following best describes the contributing factors to thermal runaway in a nickel-cadmium battery installed in an aircraft? Answer. Low internal resistance intensified by high cell temperatures and a high current discharge/charge rate and a constant potential, voltage, charging system. Question. When a charging current is applied to a nickel-cadmium battery, the cells emit gas. Answer. Toward the end of the charging cycle.